Salam Sujatra to Dr. Aizuddin. Today we from Group 6 going to present our lab report on estimation of heat capacity and entropy generation. Our group consists of me, myself, Sri Nagendra Rao, Tan Piklin, Devaraj Analaki Ravi, Wan Izni Fadila binti Azmi, and Zafran bin Zainal. So, today I am going to explain about the abstract and introduction for this experiment. So for the abstract, this experiment is carried out to estimate the heat capacity of different metals provided and to estimate the entropy generated when these metals are dropped into a container containing water. First of all three metals were weighed and recorded. Then 100 ml of water was filled in a beaker and it was heated using a hot plate while submerging the copper block inside the beaker until the water reached 80 to 100 degrees Celsius. 100 ml of water was later filled into a second beaker and the initial temperature of water was measured. And the copper block was put submerged inside the beaker immediately. The second beaker was then covered using an aluminium foil to minimize the heat losses to the surrounding. The temperature for every time interval were measured and recorded until it reached constant temperature. The water was stirred throughout the temperature measure process to ensure even the heat distribution, and all the process were repeated using aluminium and iron block. From the experiment, the value for the specific heat capacity for copper, aluminium and iron is 0.5296 kJ per kilogram Kelvin, 1.3563 kJ per kilogram Kelvin and 0.645 kJ per kilogram Kelvin respectively. Then a bar chart was generated to compare the heat capacity of these three different metals. The total entropy generated for copper, aluminium and iron were 0.0627 kJ per Kelvin, 0.0578 kJ per Kelvin and 0.0728 kJ per Kelvin respectively. The heat capacity value obtained is then compared with the theoretical value, and ways to minimize the errors during the experiment is to be found. So the main objective is to estimate the heat capacity of different metals provided and also to estimate the entropy generated when these metals were dropped into a container containing water. Now for the introduction, the heat capacity, also known as the thermal capacity, is a physical property of matter that can be explained as the amount of heat supplied to a mass and give the change to temperature either increase or decrease it. The heat capacity can be known also as the limit of the material to absorb the heat. In this experiment, I show three different materials that give different of heat capacity when the material been dropped in the boiling water. In the boiling water, the temperature of the water increased. When the temperature of the water increased, the material used are also increased until one of the moments temperature of the material did not go up. It is because the material already reached the maximum of the heat capacity. These heat capacities are measured using the formula of the third law of the thermodynamics, which determine the entropies of various materials. Entropy is a thermodynamic quantity that show the system thermal energy for conversion into a mechanical work as the degree of the disorder in this system. So thank you.
Hi doctor, my name is Piklin. So I'll be explaining about the theory of this experiment. The heat capacity of a body is actually the quantity of heat required to raise the temperature of the body by 1 degree Celsius. So when two bodies at different temperature exchange heat, the quantity of heat lost by a warmer body is equal to the heat gained by the cooler body, and some intermediate equilibrium temperature is finally reached. So this is true when this cycle with no heat is lost to the surrounding. So in this experiment, the heated solid of known mass M and temperature is dropped in the calorimeter containing the known mass M2 of the cold water. So a calorimeter is actually the object that we use for the process of measuring the heat of chemical reaction or physical changes as well as the heat capacity. So the equilibrium temperature is then measured and the heat capacity of the metal are actually determined as well. And the magnitude of the heat lost by the solid must be equal to the magnitude of the heat gained by the water. So in this formula, you can see that heat lost by the solid Q solid equals to mass times the heat capacity times with the temperature T2 of the solid and minus the T1 of the solid. And the next equation is heat gained by water. So Q water equals to M2Cp times with delta T, which is T2 water minus T1 water. And the Cp water that we use here is actually 4.187 kilojoule per kilogram per Kelvin. So the Cp here is actually the heat capacity, and at the equilibrium, T2 solid is equal to T2 water. And proceed. You can see that the entropy change of a system or its surrounding can be negative, but total entropy generation is positive. The process must proceed in the direction that compare with the increase of the entropy principle, which is the S-gen, S generated more than 0. The entropy generation is a measure of the magnitude of the irreversibility present during the process. So the entropy generated can be determined from this equation. Delta S equals to mCp ln T2 over T1, and the delta S total, or the total entropy difference, equals to the metal of the entropy of the metal difference plus with the entropy water difference. So that's all for me for the theory.
My name is Isni Fadlila binti Azmi, and I will explain about apparatus and methodology. So for apparatus, we need a metal string, thermometer, 3 metal blocks, which is iron, aluminium and copper, aluminum foil, also 2 beakers, water, hot plate, and last one is weighing scale. Now I will proceed with methodology. So the first step is we are using iron metal, where iron metal is weighed using weighing scale, and then the weight of iron metal is recorded. After that, 100 ml of water is filled in the first beaker, and the water in the beaker is heated on the hot plate. And then the iron block is attached to the metal spring, and it will be inserted into the first beaker until it fully submerged. Then the metal is let to be heated until 80 degrees Celsius. So while waiting for the iron to reach the temperature, second beaker is filled with 100 ml of water, and its initial temperature is recorded. Then, when water in the first beaker reached 80 degrees Celsius, iron metal is removed and it will be immediately transferred into the second beaker. After that, the second beaker is covered with aluminium foil, and the temperature of water in the second beaker is recorded at every time intervals as in table 1 until constant temperature is reached. The water is stirred while measuring the temperature to ensure even heat distribution in the water to occur. And last one is step 1 until step 7 is repeated by using aluminium and copper metals respectively.
Okay, for this part, I'm gonna take the result part and gonna explain some of the calculation that I have done in order to get the change of entropy. So for the first thought that we have in this experiment is that the energy release is equivalent to the energy absorbed by the water. So yeah, we're gonna calculate the entropy change of the metal as well as entropy change of the water, and then we're gonna get the total entropy generated from both water and metals. And apart from that, we're also gonna find the specific heat capacity of metal at 25 degrees C. So this is the list in each. For the first one, copper, we got 0.5296, and then for the aluminium, we got 1.3563, and then the next one for iron is 0.6450. So this is the specific heat capacity of metal at 25 degrees C. And then for the entropy change of metal, for copper we got negative 0.04007, and then for the aluminium we get negative 0.0323, and then the last one, iron, we get negative 0.0434. Yeah, for the entropy change of water, we get 0.1034 for copper, and then 0.0901 for aluminium, and the last one is 0.1162 for iron. Yeah, so that's sum up for the total entropy generated for copper, which is 0.0627, 0.0578 for aluminium, and then the last one is 0.0728 for iron. Yeah, that's all from me. Thank you.
Hi, I'm Devraj Ravi. I'm here to explain the discussion of our experiment. As you see in bar chart, this bar chart contains actual CP values and theoretical CP values of copper, aluminium and iron. Actual CP values are values that we get from the experiment. Theoretical CP values that values are given to us. So as we compare, the actual CP values are more than theoretical CP values of these three metals. The total entropy generated was discussed by Zafran in results. As we move into the first discussion, which are sources of error and method to minimize the error. Before each experiment was conducted, the cylinders and other equipment were washed to avoid slight changes in temperature since it was in contact with hot material before. It was also rubbed with a dry cloth to make sure it was in a neutral state of temperature. The errors may be reduced by having a perpendicular eye level during the thermometer reading. Otherwise, the thermometer may be dried by dried cloth before reusing it and make sure it shows room temperature. The second discussion is justification on the importance of stirring the water in the container. Stirring the water in the tank, the heat transfer rate will increase. The hot liquid will more effectively lose heat and the fluid movement against the steel air will result in forced convection. On top of that, swirling the liquid will distribute the same heat throughout the liquid in the beaker as it will maintain its thermal equilibrium with the metals. The hot metal must be quickly transferred into the water as metals are in excellent heat conductor. The last discussion is justification on the importance of transfer the hot metal quickly into the water. The hot metals should be transferred into the water quickly to prevent further heat loss to the surrounding that can affect the outcome of the experiment, because the minimal amount of heat is lost from the metal into the air once the metal is removed. The temperature will begin to be near room temperature. The lesser energy is released in the air, the quickly it transfers and more energy is released in the water. That's all from me. I'll pass it to the next person.
Hi doctor, it's me again, Pek Ling. So I'll be concluding this experiment. So in conclusion, the objective of this experiment is achieved. The specific heat capacity of the three metals, which is iron, copper, aluminum, are obtained. The entropy of the whole system is calculated by applying the specific heat capacity in the formula, and the specific heat capacity for the iron, copper, and aluminum are 0.645 kJ per kilogram Kelvin and 0.5296 kJ per kilogram Kelvin, as well as for the aluminum is 1.3563 kJ per kilogram Kelvin. The entropy of the system for iron, copper, and aluminum generated are 0.0728. This is for the iron, 0.0728 kJ per Kelvin, and for copper is 0.0627 kJ per Kelvin, and finally for the aluminum is 0.0578 kJ per kilogram per Kelvin respectively. So that's all from me. Thank you.